Mm-hmm. Okay. We're going to be doing some problems of stereochemistry. So this is about finding a relationship between molecules. So stereochemistry and how they are related. Options are, say, same molecules, so identical. They may be enantiomers. They may be diastereomers. They may be constitutional isomers. So again, options, same, enantiomers, diastereomer, constitutional. This is what we're doing here in this molecules. So now, first to remember things a little bit, I'm going to just make a drawing, a tiny drawing here. Let's see. This compound is 1, 2, 3, and 4. This is 2-butanol, but it's also R2-butanol. So priority 1 is the OH. Priority 4 is the H, which is in the back. And let's draw it here, tiny, tiny. And so then priority, if this is 1, priority 2 is to the right. Priority 3 is carbon number 1, and the 4th is in the back. So the stereochemistry here, the absolute configuration of the chiral center is R. So when I can draw the mirror image, and if I draw the mirror image, and this is to remember, and then again, hydrogen is on the back, priority 1, priority 2, this chain, and priority 3. So this is S. So notice that I did the mirror image, and I have one chiral center. That is the enantiomer. So it is the opposite, exactly, the absolute configuration. You can draw, if I say, I'm going to do another drawing of the same enantiomer. Say that I'm here, and I'm doing this, or this molecule. If when I do that and rotate 180, I'm going to do this, 180, that rotation. When I do that, what's on the right is going to go on the left, and what's on the left is going to go to the right. Again, see this two, right, left, 180. But if they are like that, one wedge and one dash, and I do 180, they also change places. So here you're going to have then the OH is going to be on dash, and the hydrogen is on wedge, and I'm just drawing it so that you remember that. So notice that this is the same molecule, just rotated it. So same. So there is two drawings of the same molecule. These two are the same, and they are the enantiomer to that. So the enantiomer will have the opposite absolute configuration. All right. So having said that, to remember, we will analyze the molecules that we have here in this picture. So first, I see these two are not mirror image, but let's see about the configurations, like I did here. Configuration of that chiral center was inverted. Now, the molecule here has two chiral centers, so I'm going to star those. And if you see here, wedge, dash. So that configuration is inverted. The metal is in dash, here is in wedge. Because the two chiral centers have inverted, so the opposite configuration, these two molecules are related as enantiomers. Again, one switch, and here you're switching OH and H, this two. One switch, it changes the absolute configuration. Here it's like you're switching the metal with the H that is behind. And so configuration has changed, the absolute configuration has changed. The two chiral centers are the opposite configuration, so they are enantiomers. So now let's get to the molecule down below. Okay, now for the molecule below, let's see what we have. Notice that if let's say that I name this 1, 2, 3, 4, and 5. This molecule is 3-bromo pentane. This molecule right here, the connectivity is different. So let's see, this is carbon 1, 2, 3, 4, and 5. So this is 2-bromo pentane. 2-bromo pentane. And this happens to be a chiral center. So in the configuration here is priority 1, priority 2, priority 3. So this is S. Remember, your priority 4 is hydrogen. It is in the back. So, but what had happened here? 3-bromopentane, 2-bromopentane. The connectivity is different. So bromine is here connected to carbon 3. Here is carbon 2. So these two are constitutional isomers. Okay, now moving on to this one. Let's see what we have. Here we have a metal and metal here. Say metal, ethyl, metal, ethyl. But what do we see here is that, let me draw it better. Here, ethyl and wedge. And here is methyl and wedge. So these two are switched, as you can see. So similar to this one here, I did a switch, OH and H, OH and H. So what we see here is that the chiral center here, this part of the molecule is the same. Oh, did I copy that right? Wait a minute. Yeah, I did. So what I have here is that these two have switched. Now I have the ethyl unwedged and the metal unwedged. What that means is that the configuration of the center is inverted. And we can do it, but let's first analyze the configuration. Now, at the other chiral center, notice that I have ethyl, metal. Metal is on dash. Here I have ethyl, metal. What had happened? These two have switched places. So one switch over here, the configuration is changed here, is the opposite. Here, one switch. This is also changed. So these two guys are enantiomers. So now let's do the configuration. The curving here on the left-hand side. Your priority 4 is an H. That's your 4 priority. And everything is carbon, so between, this is the, say, number 3, priority 3. In between these two, this one on the side has higher priority. So and that, so I'm going to do 1, 2, and 3. So this center is is R, and I draw an N. Is R. So there's got to be the opposite, and let's do it. So here you have the H also is in the back, but now I have priority 1, and then priority 2 is the ethyl, priority 3 is the metal. So what I'm doing here, I'm doing this, so it is S. So that center is inverted. Let's do the configuration of the next chiral center. For the next chiral center, remember that you have here an H, and that H is now pointing towards you, your view. So, and this is your priority 4. So the metal will be priority 3 between these two chains. This chain on the left has higher priority than that on the right. So we're going to do mentally this one switch. We need to remember to switch back. So I'm going to go 1, 2, 3. It's going this way, but I'm looking at that incorrectly. The H is pointing towards me, not away from me, which is the rules. So if this is doing that, this means this is S. So again, you're doing priority 1, priority 2, 3, looks like R, but you're viewing it that incorrectly, say with the H pointed towards you. So it is really S. So it's looking R, but it's S. So this is RS. The center is inverted. Let's do the other. Again, at the center, I will have the H pointing towards me. So whatever I do is going to be the opposite. So 4, so priority, I'm looking at this chiral center, right? So priority 1 is this chain, priority 2 is the ethyl, and priority 3 is the metal. And now I'm going to do 1, 2, 3, looks like S, but really is R. what we see here, RS is R. These two have R enantiomers. The two centers are inverted. Let's do this. Let's see what happens. So there is one chiral center here, and this center has ethyl propyl methyl. But this is simply, it is the same molecule. Notice here, in same configuration, this carbon right here that I'm putting the dot is a chiral center and is attached to an ethyl, to a propyl, into a methyl. It's just rotated. So, but it's the same molecule. So you're going to answer here, same or identical. Identical molecules. And again, constitutional was that, different connectivity. Here, connectivity is the same. So now our last example here. Let's analyze center by center. So this carbon has a methyl and ethyl in all of that chain. In that chain, well, if you see this is methyl butyl. So here the carbon, this carbon has methyl ethyl, so similar, the substituents. And the next carbon here, methyl butyl, methyl butyl. So connectivity is the same. So they're not constitutional. But let's see what happened with the absolute configuration of the chiral centers. I have two chiral centers. So this center here, notice that I have the methyl on dash, ethyl on wedge. This is now, we have one inversion. So here you're switching the hydrogen, which is here in the wedge. I'm going to draw it like tiny here. And you're switching it with the metals. Here, the hydrogen is like that. See, these two are switched. So the configuration of this chiral center is inverted. Now for the next center, chiral center, you have butyl and methyl. The methyl is on dash, and here in the butyl is on the solid line. What you see here is that these two have switched. Now what is on the solid line is a methyl, and what is on wedge is the butyl. 1, 2, 3, and 4. So another switch. So both carbons had undergo one switch. So this configuration is inverted. This configuration is inverted. Therefore, because the two chiral centers are inverted, these two molecules are enantiomers. All right? Okay, we're going to do one more of these in another video.